Hello, my name is Thomas Francis. I'm head of product management for UberCloud. We're a company here in the Bay Area. And my co-presenter today is Mohan Potheri. He's an architect at VMware. And our talk is titled Agile HPC for VMware Cloud Foundation and UberCloud. So in this talk, we'll cover a couple of use cases that are perhaps a little bit different than the traditional HPC use cases. So in traditional HPC, we're usually talking about supercomputers and exascale, but there's a whole segment that doesn't quite need exascale yet. But they have outgrown their workstations and servers, and they typically need what we like to call starter level HPC. So that's the segment that we'll be talking about. And what they care about and the tools that they need may be slightly different from the traditional HPC. So we'll focus on those tools. So folks who can do work for running simulations, for example, and maybe they have access to a few servers, now they're actually able to get what we can truly call HPC. And of course, the enabler for all of this is the cloud. So our focus is to really make it as easy as possible for this segment of the market to get access to HPC solutions. These are HPC solutions that they could never have access to before, but in the context of cloud, that's suddenly possible. But this segment is quite a bit different from the traditional HPC segment. So, for example, in traditional HPC, the focus might be on tight coupling, so static infrastructure and tightly coupled workloads. But this new kind of segment that's this HPC for the masses, their focus might be things like portability and user experience. They may place a premium on those kinds of capabilities as well as performance. But we'll see how some of the technologies from VMware and from UberCloud, such as containers, can help solve some of these challenges. And the other focus of this presentation is to talk about how we can bring enterprise IT and HPC a bit closer together. Right? So HPC has always been this silo that's a little bit outside of the regular IT landscape. But now with things like containers and Kubernetes, which Mohan will talk about, maybe there's a way to bring these two different sides of the house together. And there's a lot that HPC can learn and adopt from enterprise IT, one of which is what we'll be talking about, which is agile, flexible infrastructure. So let me just advance my slide here too. So the agenda is Mohan will start off by talking about traditional HPC architecture, and we'll slowly slide into a path to an agile HPC infrastructure. Mohan will talk about a few announcements from VMware that are very interesting and exciting for folks who are interested in containers and Kubernetes. And then I'll take over and talk about how UberCloud builds and deploys HPC containers with applications for, let's say, computer-aided engineering, for example. And then we'll walk through an actual example deployment so you can see all the different parts of the stack and how they all connect with each other. So I think at this point, I'll hand off to Mohan here. Mohan?
Thanks, Thomas. Can you hear me?
Yes.
Okay. So we will first look at the current state of HPC. I mean, particularly in the starter HPC space, like Thomas has mentioned. Majority of enterprises and HPC users are in the space, right? And so we look at what, here we see a bare metal cluster. Each of these components are kind of typical HPC components. They require their own compute usually. All these roles have different compute nodes associated with them, the different types of nodes used for different aspects of the architecture. And what we see is these kinds of legacy bare metal HPC environments, there are mixed periods of heavy and sparse utilization. So these are like, to some extent siloed by department or group, and then so there are times of heavy utilization and there are times of sparse utilization. And also, due to the complexity and the cost associated with it, the traditional hardware refresh cycles for these environments are 3 to 4 years typically, and making them a little bit static. And some of the components shown here, like the login node, the head node, and stuff like that, are usually single points of failure. That means if those components go down, potentially the application becomes unusable or partially usable. So those are the types of things that the traditional HPC architecture has. It does provide the best performance because it is bare metal with no layers between the workloads and the infrastructure. Next slide, please. So in the enterprise HPC today, we have all these new variety of devices, right? Accelerators like high-speed network cards from Mellanox, FPGAs, GPUs are common in the HPC environments. And these are complex to manage and maintain, and then they are like they are pretty expensive to add on, and then they need to be put to best use and to kind of to be able to leverage their capabilities. And if you look at workload management, from workload management, there are all these different workload management and batch processing tools out there, Kubernetes being one of them, and which is the most upcoming one. And so we are dealing with also, as I mentioned earlier, a dormant infrastructure to some extent, because this hardware is, once we purchase it, it's like has to be kept static, and is usually refreshed every 3 to 4 years. So what is the business impact of this, right? The business impact of this is for slower innovation, management complexity, and since a lot of times things are siloed, there is a lot of higher costs associated with it because the infrastructure is not being shared as effectively as it can be. So almost 80% of the cost in the budget and all in these environments goes towards keeping the lights on. And so that's kind of what we hope to solve with the cloud paradigm, right? And what the cloud provides you is the agility factor and keeping up to date with technology and the ability to share and utilize the infrastructure in a more efficient manner. And that's kind of where we would go with a cloud-based HPC infrastructure. So next slide, please. So imagine a typical enterprise with multiple groups having their own individual HPC environments. What virtualization provides, virtualization has been there for 20 years now, right? And what it's provided is that it provides a means to aggregate and consolidate these environments. HPC has typically stayed bare metal, like the diagram I showed earlier. Even now, almost 80% of the environments are bare metal. But with the world of cloud and the public cloud and Amazon and Azure and GCP, and we see that companies are moving their HPC workloads to the cloud. And one important thing about these cloud environments is all these cloud environments are virtualized. So the usual worry about virtualization was performance, right? There's some degradation that comes from having a hypervisor between the hardware and the actual workload. But over time, these virtualization environments have been optimized in such a way that there's minimum overhead while all the benefits of virtualization can be leveraged. So in the case of VMware virtualization, we have the workload is being encapsulated and isolated from the hardware. And so because of that, multiple virtual machines can share the same physical hardware. Crash or failure of a particular workload does not impact other instances running on the same hardware. This is not the case in traditional bare metal environments where if there's a crash, the entire server goes down. The state of any virtual machine which is running a HPC workload can be captured in the form of snapshots to reproduce and share interesting configurations and scenarios for future use. In the event of a hardware failure, vSphere HA, VMware HA high availability moves the workloads to other healthy nodes in the same cluster, providing fault resiliency in the environment. Many components of HPC, like I mentioned, like the login node and the head nodes, are single points of failure. Downtime of these components can be minimized through virtualization by leveraging vSphere HA. The other aspect is what we call VMware DRS, a dynamic resource scheduler, where VMware actually, at a cluster level, looks at imbalances and hotspots and migrates VMs in such a way that the entire cluster is evenly utilized. And that way, we avoid hotspots and make sure that all workloads get adequate performance that they need. VMware has also constantly been re-engineering to ensure that our performance is as close to bare metal as possible. And that is kind of why we feel virtualization, it is now the time for virtualizing all the HPC workloads as the more and more environments move to the cloud. Next slide, please. So let's look at what the road to take the HPC application to the modern cloud-based architecture looks like, right? So we have VMware has this concept called a VMware Cloud Foundation. This is the foundation where it includes all the components of VMware, which includes vSphere and vSphere for compute virtualization, NSX for network virtualization, plus storage virtualization. All these components are put together in what we call as the VMware Cloud Foundation, which is VMware VCF, and it provides the ability to make your HPC workload nimble and agile and mobile and scalable, right? And then we combine that with Kubernetes as the orchestrator. Most of you I'm sure, are familiar with Kubernetes, which came from the microservices world, but it is also very relevant to HPC because HPC applications are harder to deploy. Imagine by containerizing these applications, you are able to easily deploy the HPC applications because they are all packaged in a container, and Kubernetes provides you the right platform or the upcoming platform with a lot of tools available for management to run containers. Then we take so HPC containers typically can run on Docker or Singularity depending on the type of application. UberCloud chose the Docker containers as it's the most commonly deployed way of containers are being deployed. Right? So UberCloud containers actually package HPC applications inside Docker containers. We will show that in a demo later in this presentation. And they run on top of VMware vSphere and with Kubernetes to kind of provide the bridge between the traditional HPC and move it to the modern architecture. By doing this, you're actually leveraging your existing servers because we can virtualize your existing bare metal hardware and then add all these capabilities on top of it through the vSphere platform. And we are also able to address all your rapidly evolving business requirements because we are now, agile and cloud-like, and so any of the new business requirements and all the new applications that come, we're able to provide the compute necessary with this kind of an architecture. And then by doing this, we're able to actually accelerate the HPC application lifecycle. Next slide. So VMware Cloud Foundation 4, which is includes the new vSphere 7, is where VMware, which is announced last month and is now GA, unifies the world of Kubernetes with virtual machines. VMware has actually leveraged Kubernetes to re-architect its vSphere platform, and it extends it to all modern and traditional applications. So vSphere with Kubernetes provides the following major innovations. It unites vSphere with Kubernetes. When it does that, it embeds Kubernetes into the control plane of vSphere by unifying control of compute, network, and storage resources. It converges VMs and containers using the new native container service that creates highly performing, secure, and easy to consume containers. It provides for app-focused management, where we have app-level control of policies, quota, role-based access to developers and users. It applies vSphere features like HA, vMotion, and DRS. And it provides unified visibility into vCenter for both the Kubernetes side and the VM side. So here, the last but not the least, you see that the developers and IT ops can now, really collaborate. Developers can use Kubernetes APIs to access the data center infrastructure. IT operators can use the vSphere tools to deliver Kubernetes clusters to developers. So both, there's a consistent view between dev and ops where Kubernetes constructs in vSphere. Enterprise can expect to get improved economics due to the convergence of Kubernetes, vSphere, and containers. Operators get control at scale by focusing on managing apps versus managing virtual machines. Developers and operators collaborate to gain increased velocity due to both of them looking at the same tools, using the same infrastructure. Next slide, please. So in summary, combining vSphere infrastructure with UberCloud containers can provide choice of running your HPC applications in private, public, or hybrid clouds. VMware platform is available on-premises or with cloud providers like AWS and Azure and GCP. So you can run your environment anywhere with the same tools and the infrastructure without having to port your applications. So sharing the infrastructure across, it also helps you share your infrastructure across HPC, big data, and AI applications. By consolidating your application infrastructure, it provides improved scalability and the ability to solve more complex problems in a shorter time. The infrastructure also provides security between applications and enables multi-tenancy. So if you have multiple groups within your organization, you could consolidate all that infrastructure together, while at the same time providing security to this multi-tenant environment, so that each group gets its own compute in the environment without any crosstalk between these environments. And HPC applications benefit from the agility with unified operations and rapid delivery in a cost-efficient manner. So now I'll pass it back to Thomas to continue with the UberCloud solution.
Great, thanks, Mohan. So we heard about how virtualization can offer some benefits to HPC by improving the agility of the infrastructure. And we talked about the sort of the traditional HPC requirements, such as speed and performance, and some of these new segments, which are kind of the starter HPC, which where things like user experience and flexibility and self-service may become a little more important. And one of the other technologies that enables that sort of self-service agile infrastructure is containers, in addition to the virtualization. And containers, I think it's familiar to most folks, started in the enterprise, and really was started by developers trying to build microservices. It's a core feature of the Linux operating system, and essentially it virtualizes the operating system, or more specifically the kernel, right, versus a VM, which virtualizes hardware. There are some very interesting or useful capabilities of containers that are interesting to HPC workloads as well. One of them is they're extremely portable, so across hybrid infrastructure, with hybrid being the new normal, right? With on-premise, a mix of cloud, public cloud, hosted, having the ability to port these applications across different infrastructure, different clouds even, becomes very important, and that's something that containers can provide. Containers can be updated continuously. I'll talk a little bit about how that works, but with this new paradigm of hybrid infrastructure, software and hardware changes all the time. So in traditional HPC, hardware is relatively static, but in kind of this new world, for example, cloud providers are constantly pushing out new features, and if you want to leverage those features, you have to find a way to somehow incorporate those new features. And containers are a good way to constantly keep up to date with those new capabilities that are coming out from various services. And finally, we talked about this, but it really could be a bridge between HPC and enterprise. So, for example, containers are really the new application deployment standard for enterprise. Most applications are being deployed in containers on the enterprise side of things. So if that's the case, and Kubernetes becomes the single kind of control plane or management stack for containers, there's a way we can use Kubernetes to manage the HPC side as well. Then we can envision a world where enterprise workloads and HPC workloads kind of share the same control plane, and there's a lot of economies of scale, et cetera. Again, this is not for every kind of HPC workload, but there's a whole segment in the middle there which can really leverage this. So essentially, all the stuff in the green here in this stack can be encapsulated in some way or the other by the container. So if you start at the top, we have some CAE applications, computer-aided engineering applications, Siemens, perhaps Star CCM CFD application, or here and Dassault, maybe and then you have middleware tools such as Univer Grid Engine, which provides job management and workload management. And then there's the operating system itself and associated libraries, for example, for MPI. And then there's specialized infrastructure integration. So cloud providers are now offering things like InfiniBand high-speed networking, right? So libraries for those, all of that can be packaged in the container. And then basically anywhere there's a Docker runtime available, those containers can be operated. And that runtime is available on any of these different cloud providers or on-premise clouds. So just to recap, these containers are based on Docker, and they're enhanced for engineering and scientific applications. So all the tools and the end user application and remote visualization, all of that is packaged in the container, and it makes all of this completely self-service. So we'll look at a kind of a workflow of how that works. But then the question becomes, how do you build these containers? And again, we can look to enterprise for some of the answers here. So there's this CI/CD, continuous integration, continuous delivery mechanism, which is very familiar to folks in the enterprise. This is how applications are built and delivered. We can use the same kind of capability to build these HPC containers as well. So the CI process, which is the continuous integration process, basically builds the container image, does some unit testing, security testing. All of this happens automatically. So there's no human intervention here. So there are tools that do all of this. And then it switches over to the deployment part. And there it goes through the proper stages, isolated testing in a staging repository where only authorized users can access it. So it provides the proper separation of concerns, et cetera. And then this container can be deployed automatically in any kind of infrastructure, data center, cloud, et cetera, making it extremely flexible. And since containers are pretty self-contained, they have all the configuration, libraries, application that are needed to run the workload. You can build them once and then deploy them in multiple places. And then when you need to patch them or upgrade them, the same cycle can be leveraged to do that in an automated fashion. So the CI/CD process will do container provisioning. It'll retire old versions as they become obsolete, and it'll implement new versions transparently. So let's just look at an example deployment. There's a busy slide, but if you look at this left side of this slide here, everything up to here, this top half is all basically just setting up VMware. So think about an enterprise which already has VMware running. So all of this is already done, right? So you have a ESX and you have vSphere, all of that stuff is already set up. All you need is the application and the MPI and all of the HPC stuff, which comes in the form of the container. So the container is pulled and instantiated, and you can run it. One key capability that this stack provides is basically end users can self-service themselves. So it's on-demand access. So an end user can basically go in and they have a simple portal where they can create an HPC cluster for themselves, just for their personal use. They can expand that cluster as much as they need, add as many compute nodes, for example. They can shut down the compute nodes and basically terminate everything. So everything in here, at the bottom here, is something that an end user can do. But think about how powerful this will be for folks who don't have to wait for an overloaded HPC administrator to provision infrastructure for them. So this is something that they can completely do on their own. I'll show a short video here which shows some of these capabilities. So basically what you'll see is VMs getting provisioned by VMware and vSphere, including a tool called Terraform. And then once those VMs are ready, the UberCloud container is pulled with the Ansys application, and the container is started up. And when the container starts up, it automatically sends out an email to the end user with login credentials, with a one-time password. The user can log in, and they get a full browser with a fully interactive version of Ansys that they can start using. And then they can start expanding out that cluster by adding more and more compute nodes. And if they want to run interactive, they can always run batch workloads as well. We'll see a little bit of that as well. So let me just start this off here. So you can see that the VMs are being provisioned. All of this is controlled by templates and completely configurable based on different hardware. So all of this infrastructure as code, as they call it. So everything is done with code. And at this point, the compute nodes are available on VMware. And now the UberCloud container is being pulled and extracted. So the application is now being installed. And all of this is completely automated. And as soon as it's ready, an email is sent with credentials to the end user themselves, and they can just log in to run an application such as Ansys and run it on as many cores or servers as they need to. And this is a fully interactive use case that we're looking at. But as I said, you can add as many compute nodes as you need. It could be 3 here, it could be 30 or 300. It just depends on what the workload that user is interested in running. Shortly, we'll see. Yeah, so if you want to run a batch workload, you just encapsulate this Fluent application in a wrapper script, and that can be submitted. You can have as many processors, 100,000, whatever, and send the job over to the cluster. The convergence happens, and the job is completed. Okay. So on our website, we have a number of case studies that you can take a look at. These are all free case studies that you can download. I think there's about 20 plus engineering case studies which involve containerized applications. So as sort of hybrid infrastructure is the new reality, managing that complexity of hybrid infrastructure that we talked about earlier with all these different hardware configurations and applications becomes challenging. And as organizations are getting more and more constrained with data center space and environmental considerations, public cloud is getting more important. And so as these range of HPC workloads expand to include things like big data and AI, et cetera, the level of complexity becomes really acute. And fortunately, there are technologies from VMware and container technologies and Kubernetes that can really help you manage these applications very efficiently and really get the benefits of this hybrid infrastructure. All right, thank you very much.
Any questions?
Yeah, we do have a couple questions here. One is, what is the additional latency cost for the level of abstraction in the HPC environments, and does it add jitter to IPC or RDMA operations?
So the typical performance testing we've done, we have like a 3 to 4% overhead from virtualization. So, but a lot of the things that we typically do in the case of MPI, for example, literally, if you have a full node in a bare metal environment, a full node is actually dedicated in a virtual environment as well. So there'll be only one virtual machine running using the the hardware, like using the Mellanox card or the InfiniBand card. So when we do that, the kind of overhead we've seen is like 4 to 5%.
Yeah, just to add about the latency. So public clouds now are starting to offer Mellanox InfiniBand hardware, right, which you can run RDMA applications on, and those offer the same, sub 10, order of 5 microsecond latencies that you can expect to see in an on-premise environment. So that is available as well in public cloud.
Okay. And the next question is there a fee to use the cloud? Maybe it was missed in the early part of the presentation.
Yes. Go ahead. Yeah. So the fee, yes, of course. Basically what you're doing is you're outsourcing your hardware purchases to the cloud providers. So rather than spending your money on capital purchases, you're basically converting that into an OpEx for which you're handing over to the cloud provider, and the promise that is that the economics will work out in your favor because cloud providers have economies of scale and so on. So that's really the kind of final answer. But yes, there is a fee, and the cloud isn't free for sure. So, but the nice thing about what you can do here in the cloud is you can tailor your workload to you can have much more granular control as to the kind of hardware that you use. So it doesn't have to be an all or nothing kind of thing. So maybe there are some workloads which you want to use in cloud, but keep some of the other workloads still running on-premise.
And the other aspect, one important aspect, is that the solution like UberCloud, you would instantiate the instances in the cloud on an on-demand basis, and then once the job is done, you destroy it. So that way, you're using the cloud provider only during the period that the job is running. So that's a big advantage.
Okay, and finally, and I apologize, Christopher Baker, if I'm not reading this correctly, but is there a virtual container HPC cluster that possibly can match systems on the top 500 list?
I don't know the answer to that, but it seems unlikely. Top 500. So as we kind of started off by saying, these are for folks who are graduating from workstations and a few servers. So they're at the lower end of the spectrum of HPC, what we would consider HPC. And that's a huge segment too, right? So I wouldn't think that although we have done benchmarking at Lawrence Livermore, which at the 1,000 core scale, not at the top 500 type scale, and as Mohan mentioned, the performance hit is about 3 to 4%. So the question is that hit worth all the other benefits that we talked about, the self-service and that virtualization can provide? Yeah.
So the one thing I want to add here is, if you think about the high scale examples that Amazon or Azure, AWS or Azure has, they are, if you think about it, if they showcase something really highly performant, it is actually virtualized. So those could be our examples. Since these cloud providers have the infrastructure, they can actually scale up to any level, and so they can potentially compete, but there's always some overhead.
Okay. And that was the last question. So thank you, Thomas and Mohan.
Thanks for the opportunity.